Hey, what's going on, guys? Come back against the hero. Last video we ended up with probing NNUE weights file using the FEN string as an input, but if we would have been converting a current given position into FEN string and then probing it and then getting a score, it would be extremely slow. So obviously there is a better way of doing things, and we can simply probe NNUE weight tables directly. So in order to do this, we have a function that we have wrapped in our NNUE eval.h. So the function is called simply evaluate NNUE, and if we have a look, well, we don't even need to have a look at the initial function. So what we need to pass there is, well, player is the site to move. I just kept the in my engine this is called site. Sorry, guys. But I just kept this player as it was named in the probe library, in the NNUE probe library by Daniel Chevel. Just decided to keep this variable name. And also we need to send the pointers pointing to the verb first element in the arrays called pieces and squares respectively. So the piece of code that I'm supposed to be writing in this video could have been actually skipped because it only slows down the performance, but on the other hand, it allows to see what in particular we need to extract from a given position. Well, because again, like if this was only the matter of embedding NNUE to BBC chess engine, which I'm working on, then this video could have been skipped. But assuming that you guys might have absolutely different engines, it might be tricky to realize how to apply this technique to your engine. So that's the reason why I decided to make this video, going extra mile, but just to make it sure that it would be also easy for you guys to implement in your engines. And again, like first I will create this more slow but more clear implementation, and then I would obviously optimize that, and probably that would make a little bit more sense to you as well. So I would be reusing some code that I've written before because we need to be really precise here, and I don't really want to make some typos that would be leading to horrible results. So I would be reusing my code slightly a little bit, and I would start with NNUE input, I guess they call that. Okay. So here I did create a function to, well, literally all this function does, it actually gets the piece and gets the square from a current given position. So we have, and we would be initializing two arrays here, array of pieces and array of squares respectively. So, well, and then we would be mapping both pieces and squares as well. So I would probably now just grab this map and arrays and paste them to BBC, and then I'll be walking through every one in particular to give you an idea what is that doing. Evaluation. So I don't know where to put it basically, but I don't know, maybe from the very beginning here. So this array is needed in order to map map BBC piece codes to Stockfish piece codes, and so I don't really need this one in particular at the moment, and this one is needed in order to map BBC squares to square indices. Oh my god, I forgot how to write this. Hold on, guys. Okay, sorry. So this is the right way to write the word indices. I just forgot how to spell it correctly. So map BBC square indices to Stockfish square indices. And I want to emphasize this part especially because this is one of the core concepts here. So if we just have a look at BBC's square and piece definitions, I just grabbed this to compare them to give you an idea. So what's kind of the difference there? So let's just make it. I just want to make them to comment them out. So, well, I think board is quite pretty self-explanatory already. So A1 in BBC starts here, and in Stockfish it starts here. So this is the matter of the board and the antis. Now, in order to so we have some requisites in regards to Stockfish's both piece encodings and square encodings. So if we go at our NNUE probe library to NNUE CPP, then here, thanks to Daniel Cheval, well, probably it's here, he did kindly provide how actually one can deal with this, both piece mappings and square mappings. So let's start with the square mappings. So the squares are A1 equals to 0, H8 equals to 63. So what I want to say by saying this, so that the idea is that, well, let's say I have, so this is the initial BBC board. So let's say I have a square, a piece on say on A1, and I need to, if I just retrieve a square index for piece A1, it would give me, well, I'm not sure. So this one probably 60, 59, 58, 57. So probably it would be something about 56. Not sure, but anyway. So, well, let's say this would be 56. But the index of 56 here is actually A8 and not A1. So that would be just a round square. That means that we won't actually get the right values from the NNUE weight tables. So we need to make sure that that we convert square indices of our engine to match the square indices in Stockfish. So just to give you an idea, what am I trying to do? So here I'm just doing what they asked me here. So we say like A1 should be equal to 0, H8 should be equal to 63, and this is exactly what I have done. So A1 is the value of, well, let's say I could have actually make it more calculated more precisely, but I guess this is 56. So let's say A1 is equal to 56, and actually, if I did extract the square with the index of 56, I need to convert this 56 to Stockfish specific square code, square index. So I'm just okay, how to call this? Okay, probably I found a way how to explain this. So this is my pre-coded stuff here. So what we are doing for every square that has a piece on it, we're referencing this NNUE squares. So we're referencing this array by the square value. So let's say we extract some sort of a square value, and if we just extract the square value of, well, which one to pick? Let's say the square value for A1, right? So this is 56. Then instead of 56, we actually need to return 0 because A1 would be equal to 0. Okay, I'm sorry, I just this does work, I swear. I just losing the thought again and again. So whatever index we have, so this, okay, if we just try to take this A8, I know sometimes it's far easier to implement rather than to understand, but assuming that you would probably be doing this on your own and you would have a slightly different, if you have the same board NDNS as in Stockfish, you obviously don't really need this at all. If you have some different board NDNS, in that case, you would obviously need to convert this. I'm just trying to find the proper words to explain how in particular that is about to be done. Well, let's try A8. So A8 is equal to 0 in BBC Chess Engine. Okay, so A8 is equal to 0. So let's say we did extract the piece on A8. So here, let's say square is equal to 0. Okay, and now we need to convert 0 square index from BBC Chess Engine to a specific one corresponding to Stockfish. So if we actually now referencing this NNUE squares by square which is equal to 0, so it will return us A1, and A1 is actually this one, the value of 56. So this means that index of 0 would be converted to 56. Oh my god, I did finally manage to say this. Okay, so I hope this is clear. This is something similar what we're doing when we're mirroring the evaluation for white and black respectively. So, well, I hope this is clear. If not, just leave a commentary below this video. I will try to explain this again. I don't know, like, I thought this is easy to explain, but not really that much. So, just try to get the idea. So the idea is we actually need to make sure that we convert a square index in our engine to correspond to what kind of square index it would be in Stockfish's board representation, board NDNS, call it however you want. Okay, I hope this is clear. Well, maybe it would get a little bit more clear with piece encodings, because here we're actually doing literally the same stuff. So I just get rid of this board at the moment and switch to pieces to explain them as well. So initially in BBC I have the following encoding. So this is white pawn, white knight, white bishop, rook, queen, king, and the black pieces. So I have first pawn and then goes to queen, and then again pawn, and then again goes to queen. Now in Stockfish that it's going a little bit different way. So we have white king in Stockfish is encoded as 1, queen as 2, rook as 3, and so on. And for black pieces, 7 is king, 8 queen, and so on. So let's say that we did pick up, a white pawn as a piece in our, well, let's say here, right? So we did pick up a square, and yeah, also we did pick up a piece. So white pawn is equal to 0. But if we just use this 0 when passing to an NNUE evaluate function, it won't be working correctly, because in Stockfish 0 means not a pawn. It doesn't even have a piece equals to 0. Okay, so it just most likely just won't work at all, just crash. So we need to convert our pawn to re-encode this to make it like a Stockfish pawn. And what we're doing here, so we have this P as an index, and now we just indexing NNUE pieces by the piece code that we've just extracted. So in this case, for white pawn, this would be 0. So here NNUE pieces indexed by 0 would be equal to 6. And let's have a look. What does that mean? So 6 is exactly white pawn. Great. Now let's say white knight. So in Stockfish this should be 5. So if we have here we have white knight index of 1. So we just reference in NNUE pieces index of 1, and we're getting the value of 5. And respectively, yeah, we're having this white knight. So I hope this is quite pretty self-explanatory and clear. So everything the same goes for the opposite pieces. So if you have some different piece codes for your pieces, it doesn't matter really, but you just need to make sure that when it comes to passing the data to NNUE evaluate function, you need to have your piece codes in the pieces array and square codes, square indices in the squares array exactly the way so they match in Stockfish manner. So like it makes sure that you need to convert your own pieces to your own piece code to Stockfish piece code, your own square indices to Stockfish square indices. Only in that case it would be working properly. Otherwise, you would be getting some really nasty errors, and most likely your engine would be crashing all along the way. So, well, I hope this is clear. And again, like here, I'm going for some sort of a duplication. So I've created this function NNUE input. The idea behind this function is actually to initialize the pieces in squares array. Just in order to save you time, I'll probably just grab this function, paste it in, and show you how it works. Yeah, and then in the next video, I will embed this into the evaluation function, because I have absolutely the duplicating code. Well, if I not only deleted my normal evaluation, like handcrafted one. Well, anyway, so. I will just now try to take this function. It would be I will delete this in the next video, obviously. But at the moment, well, actually, I have already. Yeah, I have already even. Yeah, this is from my previous. Yeah, this is from my previous attempts. Well, anyway, so just need to copy this one, and. Save. Now let's go to down below here, paste. I will now walk through the code, like what in particular is this code doing, and where did I take this code as well. I just don't really want to type it by my hands, just in order to avoid some nasty errors. Okay, so well, I could have actually tried to run this first. Could have tried to run this. Okay. Probably this would be the best way of doing things. So, okay guys, so first I'll make a test, and then I'll go for explanation. So I'm creating pieces and squares array. So the idea is that pieces array holds all the piece list, and the squares array holds all the squares that are corresponding to these pieces that we're having. And one little restriction: we need to make sure that the piece indexed by 0 is equal to actually white king, and piece indexed by 1 is equal to black king. And square 0 is the location of the white king, and square 1 is the location of the black king. So this is absolutely essential. For all the other squares, the order doesn't matter at all. So, and one more thing, not here, go into MISC, CPP, and the decode FEN part. Yeah, this is it. So this is the code that I used. Okay, so first, let's try to run this, and then, okay, so I've created these two arrays. They are not declared globally. That means that they are not initialized to 0. But we don't initialize these arrays. In order to make sure that everything will be working properly, we're actually setting 0 at the end of the array. So that's an important thing to bear in mind. So these two lines of code. Let's say and arrays with 0 terminating character. Okay, and okay, and also I want to print the score now. So, but this would be score. Let's call it direct, and new line, and the score. So let's actually try to compile and run the code. I really hope I didn't ruin anything, so it still works. Okay. Okay. Hold on a sec. Hold on a sec. Oh, it just has a different name. Okay. It just has evaluate NNUE here. Okay, and absolutely fantastic now. So we got two absolutely the same scores. I just want to make sure, just want to change the position to make sure that we have the same scores all along the way. Okay, so just need to make sure that the score that is obtained from using the FEN string is exactly the same as this one where we did provide the input data by extracting it manually without using the library function. Okay, so as far as this is working, I will now walk through this code, trying to explain how it works in particular. So if we don't, where to start? So this is the bitboard specific stuff. If you have a non-bitboard engine, if you have an array based engine, it's not a big deal for you to get all the pieces and all the squares. So regardless of whatever board representation you have, what you need to obtain? You need to obtain a list of pieces. By saying a list of pieces, I mean the list of piece codes and also the list of squares. So I will now just be providing, I'll just add some printf statement to give you an idea of what in particular is going on here. So let's say piece, and let's say, okay, I'll use the Windows version. Well, no need for that, but as far as I'm not, well, anyway, okay, so let's make it like so, and square, and I mean I have ASCII characters and Unicode characters to represent the board pieces. Let's take ASCII characters, ASCII pieces, and actually piece, and also square to coordinates, and square, and also I want to print the bare square like this. So square index and decimal 1 2 1 2. Okay, so let's have a look. Okay, and obviously need a new line here as well. Okay, so this is the list of all the pieces I have in my position. Well, let's switch back to the initial position just to make it more clear of how it's going. So just get back to the start position again, here and here respectively. So we got all the points and the corresponding squares. So like here it's kind of clear, like A2, B2, C2. So we're my engine starts with calculating, like starts recognizing first white pieces, then black pieces. That's due to the bitboard representation. Anyway, so here, well, if you have, I don't know, if you have piece list, you don't have any problems with that at all. You can just easily use that. Yeah, you can easily use piece lists if you have them in your engine. Just want to give you an idea what data do we need to get here. And also, yeah, probably would be better to use the code as well. So piece code, and decimal like this, and piece like this. Okay, so now the values that would be initializing our pieces array and the squares array. So again, like what we've done, so we've defined two arrays, and now we are calling this NNUE input function. So this function is here, and we're passing the pointer to the pieces array and pointer to the squares array, which means by saying pointer, I mean the address of the memory where the first element in the array is available at. So hope that's clear. And we're just passing this to pointers, okay? And here we are initializing them, but before we go, we come to this initialization. So let me just quickly walk through the rest of code here. So I'm defining the copy of the bitboard, piece and square variables that would be this one that are printed actually. So each piece, each square, and then I have two nested loops. So the first loop, well, in my case, I'm looping over all the bitboards. I have a global bitboard array to represent the board position. So bitboard for white pawns, black for white pawns, white knights, white rooks, etc., etc., and ending up with a black king, up to 12 bitboards within this bitboards array. So I'm looping over every one of them, and then within every single bitboard, what am I doing? I'm initializing the piece that is equal to this bitboard piece counter. So this at the same time, this serves as the piece code from 0 to actually to 11, right? And so pieces has been initialized, and then I'm getting the least significant first bit of every bitboard, and that's the way how I can actually get the pieces square. And now let's just ignore this code. In order to go to the next piece, I'm popping the least significant first bit, and that's how this loop is going on. But by popping this least significant pop bit, there is one more 0 is getting available in the bitboard. So at the very end, at the very last iteration, when only a single bit would leave on this bitboard, and we just clear that bit away, we'll end this loop at all, because there won't be so bitboard won't be true anymore. By saying true, I mean some value, some non-zero value. It would be bitboard would be equal to 0 unsigned long after we pop all the bits. But by popping these bits, well, before popping these bits, we actually obtaining this square indices for every single piece that we that is occurring on the chessboard. Okay, I hope this is quite pretty clear. And now in order to use this piece and the squares properly, as I've been mentioning in the very beginning of this video, we need to convert piece code to Stockfish piece code. And in order to do this, I'm just referencing this NNUE pieces array and indexed by the piece. And in order to convert square index to Stockfish type square index, we need to reference NNUE squares indexed by the squares. So depending on what kind of piece codes you have, and depending on by the way, yeah, so those arrays are just upper in the source code. So depending on what kind of piece codes you use and what kind of board indices, or in other words, what kind of square encodings you use, you need to adjust this NNUE pieces, NNUE squares respectively. So just again, like to give you an idea if you forgot. So here we convert map BBC square indices to Stockfish square indices, or in other words, you can not say map, but you say convert BBC square indices. Well, probably I just call it convert, so it would be more explicitly clear. So want to convert BBC piece code to Stockfish piece code, convert BBC square indices to Stockfish square indices. Sorry guys. Okay, and now the very gist of populating the array. So the first requisite has been mentioned already, was to actually make sure that the very first element should be white king and the square respectively, and the second element should be black king. So here we just ask if the piece is equal to king, and please note that here we use non-converted, but the initial value of piece. So if piece is equal to king, in this case we initialize in this pieces array at the index of 0 with the converted version of our pieces to here we're converting piece codes to it's probably better to say this. So here I want to store white king piece. Let's say convert white king piece code to stockfish piece code and store it. Well, I can actually make it like this, hopefully, and store it at the first index of pieces array. And same we have here, but for black king, and at the second index. Okay, and here we want to convert square code at the first index, and here we want to convert square code, square index to stockfish square index. Convert white king square index to stockfish square index. Okay, and here what we actually do, we convert all the rest of piece code with corresponding square codes, convert all the rest of piece code with corresponding square codes to stockfish piece and square code piece and square codes to stockfish piece codes and square indices respectively. Okay guys, sorry, been a little bit distracted. Okay, so this is it basically, and every time we deal not with either white king or either white king or the black king, we actually increment our index. Initially index is equal to 2 because the first index is for white king and the second index is for black king, both piece code and square index. So we increment this index that serves as an index for both pieces and squares. So it starts with a 2, and every time we hit a piece that is not a white king or not a black king here, we just initialize our piece square pairs with this arrays and increment in the index. And when we do this with all the pieces, it's incredibly important to actually make sure that after we've finished our initializations, we're setting up our zero terminating characters at the end of each array. So that's kind of it. Again, like already in the second video, I would be embedding this logic into my evaluate function because I already have this loop to get the piece code and p square. So I don't really need to have this separately, and this actually makes the performance it slows down the performance, not very significantly, but still. So I would be optimizing this code starting from the next video. But again, like, just to give you an idea what in particular should be done within your engine. Obviously you can skip this in your engine as well if you already know how exactly you can embed this initializations of pieces and squares into your engine. Then you can skip this and you can go directly do this in your engine. But again, like, just to make everything clear, I decided to separate this. And at the very end, what we have, so at the very end we have well, obviously, if I have the site as the global variable. If you have it somewhat different, you also need to get the site of the current the site corresponding to the current position. So I hope that would be not hard to do for you. And as far as we do obtain our pieces array and the squares array, we are already kind of be capable of calling this wrapper function evaluate NNUE, and this is it. So we're just getting absolutely the same score, and so score direct 42, score FEN 42. So you just need to make sure that the score that okay, the very last thing, just to make sure that your direct probing is correct. You need to make sure that the score that you're getting by using this evaluate FEN NNUE value would be exactly the same with the value if you're just using this evaluate NNUE and then your site and just initialized arrays of pieces and squares. Okay guys, so this is it from my side. I hope my explanations were clear. Well, at least this is something that I would like to some sort of instructions I would like to get if I only could have a video explaining that. Unfortunately, like, it's a bit pity that those really smart guys who do all this stuff, who understand all this stuff much better than I do, they don't do YouTube videos, unfortunately. And those guys who do YouTube videos, like noobs like me, they don't really have that great understanding of what they are doing. Well, that's the reason why I'm calling myself Code Monkey King every time, because not always I have that great understanding of what am I doing. But anyway, we have what we have. Hope that one day someone smarter than I would be making these tutorials on chess programming, so I would be able to learn from those tutorials. But yeah, I believe that those are only my dreams. Well, anyway guys, this is it from my side. I hope you've learned something interesting out of this tutorial. And with this ability of actually direct probing of NNUE weight file, this one, we can already now go to actually altering our evaluation function in order to make use of this score to affect the overall score that would be given by the evaluation function of our chess engine. So eventually the playing style would be just like Stockfish's playing style. There would be a couple more tricks to consider, like taking care of piece weights, scaling as well, but that would already be the topic of the next video. So make sure to stay tuned. Hope to see you in the next tutorial in this NNUE tutorial series. I wish you all the best, guys. Until the next video, and take care.